Ultrasound. In this video, you'll learn that sounds with frequencies higher than 20,000 Hz are known as ultrasound. Ultrasound frequency is too high for humans to hear. Human hearing range is 20 Hz to 20,000 Hz. Explain how ultrasound is used for sonar, medical imaging, for example baby scans, industrial imaging, for example checking for cracks, cleaning objects, which I've so asked about on exam papers over the years, and treating kidney stones, which I've also so asked about on exam papers over the years. So first things first, what is ultrasound? Ultrasound is just sound with a frequency higher than 20,000 Hz. Humans can't hear ultrasound because we can only hear sounds in the range of 20 Hz to 20,000 Hz. Some animals can hear ultrasound, such as bats, which use it for echolocation to find their way about in dark caves and locate prey such as moths. Ultrasound has many uses, such as sonar for ships. Ultrasound has a high frequency, so it diffracts less or spreads out less than low frequency waves. Ships send out a pulse of ultrasound, which reflects off the seabed, and they can work out how deep the water is. If you know that the speed of ultrasound in water is 1,500 meters per second, let's say, send a pulse of ultrasound out of the bottom of the ship and record the time it takes for the echo to return. Just say it takes 6 seconds for the ultrasound to return to the ship. If we use the equation distance equals speed times by time, we can simply put our values for speed and time into the equation and work out the distance the ultrasound travelled. Remember, that's the distance to the seabed and back again, so the distance to the seabed is half of the total distance travelled. If a student makes a mistake calculating the depth, it's often because they forget to halve the total distance, so avoid that mistake in your exams. Another use of ultrasound is medical imaging, such as baby scans. The reason we use ultrasound for baby scans instead of X-rays is that ultrasound is much safer. It has a much lower frequency and energy than X-rays, which could damage the baby. By using a transducer, ultrasound waves can pass into the body. Every time there's a boundary between two media of different densities, the ultrasound wave is partially reflected. The time taken for the reflections to be detected by the transducer can be used to work out how far away the boundary is, and a computer can produce an image of what's going on inside. For example, there's a change of density between the amniotic fluid surrounding the baby and the baby itself. So when the ultrasound wave hits the baby, there's a partial reflection and the baby's outline can be seen on the computer screen. Another use of ultrasound is industrial imaging, such as checking metal for cracks. Just say we make a turbine blade for an aeroplane. It's very dangerous for there to be any cracks or air bubbles inside the turbine blade. So once again, if we send an ultrasound pulse into the material, we'll get a reflection whenever there's a boundary inside. And if there is, it might be a crack, so it will need to be repaired. Here's a typical exam question that you might get asked. An engineer uses ultrasound on a turbine blade, and here's the trace on the cathode ray oscilloscope, or CRO for short. When the engineer uses ultrasound on the second blade, the trace is different. Explain what the traces show. Right, you can see from the first trace there's only 2 pulses. The first pulse is a reflection off the front surface of the blade as the ultrasound first enters. The second pulse is the reflection of the back surface. The second trace has 4 pulses. The first pulse is once again the reflection of the front surface of the blade. The second pulse is a reflection of the front edge of a crack. The third pulse is a reflection of the back edge of a crack. And the fourth pulse is the reflection of the very back surface. For more marks, to get you up to level 9, the examiner might ask you to calculate the depth of the crack. You'll need to know the speed of ultrasound in the material and the time for the reflection of the crack. Either the examiner will just tell you those values, or they'll tell you the speed. For example, ultrasound travels 5,000 meters per second in steel, roughly, and you'll need to look at the screen of the cathode ray oscilloscope to get the time. For example, each square on the cathode ray oscilloscope screen might represent 0.000001 seconds, and there's 2 squares from the first pulse to the crack. So that's 0.00002 seconds for the ultrasound pulse to travel to the crack and back. Distance equals speed times by time, which equals 5,000 meters per second times by 0.00002 seconds, which equals 0.1 meters. However, remember to halve it to get the depth to the crack. So that's 0.05 meters, which is 5 centimeters. So that means the crack is 5 centimeters deep into the turbine blade. Ultrasound can also be used to clean objects. The way it does it is by shaking dirt off the object. Remember, ultrasound is sound with a frequency above 20,000 Hertz. The frequency tells you how many times per second the wave is vibrating. So that's more than 20,000 vibrations per second, which shakes dirt loose, as you can see on the animation. Ultrasound can also be used for non-invasive surgery, such as treating kidney stones. Instead of having an operation to remove the kidney stones, which are little stones made from salts inside the body and can be very painful, the patient has ultrasound passed into their body, first to locate the stones, then to shatter them with high-frequency vibrations. The shattered stones can then just pass out of the body through your urine when you go to the toilet. Well, I hope the video helped you. Work hard, be nice, and bye for now.